Hello, dear students. This is your Jagan sir, and welcome back to our YouTube channel Physics with Jagan sir. And today we are going to discuss sixth class on work, energy, power chapter. And in this chapter, we are going to see our concept conservation of mechanical energy. See here, what is conservation of mechanical energy? First point, from work energy theorem, we know that from work energy theorem From work energy theorem, work done by all forces is change in kinetic energy. This is what we have seen in our last classes. And here, conservation of work done by all forces, and that means all types of work done. That is, work done by conservative forces, work done by non-conservative forces, and other than this one, and all this gives us change in kinetic energy. And see here, suppose let work done by non-conservative forces is equals to 0 and work done by other is also equals to 0. We can say that work done by conservative forces is equals to change in kinetic energy, right? And here in our last class, before this class, we have seen that work done by conservative forces is equals to minus of change in potential energy. So we know work done by conservative forces is equals to negative of change in potential energy. So can I write now, therefore minus delta U is equals to delta Ke, and here UF minus UI is equals to KF minus KI. Now UI minus UF, KF minus KI, Ki plus Ui is equals to Kf plus Uf. That is total energy, initial total energy, initial total mechanical energy is equals to final total mechanical energy. This is what is the statement says conservation of mechanical energy. I hope I am very clear from my side, right? Now let us go through some examples on this topic. Number one, a block is placed on the top of a plane inclined at 37 degrees with a horizontal. See here, I am discussing not formula oriented questions. I am discussing logic oriented questions and difficult questions, which makes you to be, if you practice these questions regularly, which makes you to be more comfortable in understanding the subject, right? So what I am suggesting is, always I am saying only one thing: once you please go through my class notes regularly and go through the class topics, and you have to understand and write by your own, and once you practice these questions your own, then you better to go solving worksheets. That would definitely give you enough amount of knowledge and confidence. First of all, you will get the confidence on the subject, then you will get the best marks, right? The question is, a block is placed on the top of a plane inclined at theta is equals to 37 degrees with the horizontal. The length of the plane is 5 meters. The block slides down the plane and reaches the bottom. So block starts its journey from here and comes to here, and find the speed of the block at the bottom if the inclined plane is smooth. Number one, if inclined plane smooth, right? And in such a case, what are the different types of forces are acting on my object? Number one, mg. So obviously we have seen this will be mg sine theta, right? And a, right? Chalo. By using conservation of mechanical energy. And here understand one most important point: the external force which makes my object to move is only gravitational force. Normal force, all are internal forces which are negligible here, which we are not considering here. Not negligible, but we are not considering them. And here only external force which is acting on my block to move block from top to bottom is only gravitational force. And we know that gravitational force is a conservative force. And if it is conservative force, we can use conservation of mechanical energy. So by using conservation of mechanical energy, I can say kinetic energy initial, potential energy initial, kinetic energy final, potential energy final, right? And kinetic energy initial is mass, and it starts with a rest, so 0. And potential energy mgh, and kinetic energy final, and they are asking us to find the speed, so half m v square. And potential energy, when object reaches the bottommost point, there would be no height, so we can write it as mg0. So which gives us mgh is equals to half m v square m m, get cancel. Then v square is equals to 2gh, 2gh, right? Now see, from diagram, from diagram from diagram, sine 37 is equals to h by 5, and sine 37 value is 3 by 5, h by 5, 5 5 will get cancelled, h is equals to 3. Then v square is equals to 2 10, h is equals to 3. I am substituting this one in here. Then v is equals to under root of 60 meter per second, 60 meter per second. And this is what is the speed of the block when it reaches bottommost point. And the second part of the question is find find the speed of the block at the bottom if the coefficient of friction is 0.25. That means here frictional force is present, and we know that frictional force is a non-conservative force, so we could not use here conservation of mechanical energy. Now by using work done by all forces is equals to change in kinetic energy, and here work is done by gravity plus by frictional force plus, sorry, equals to change in kinetic energy. And apart of this, no force is helping, and friction will act in the backward direction, mg sin theta act in the downward direction, right? And n mg cos theta, mg cos theta, right? Work done by gravity is equals to mgh, which is equals to, right, mgh, right? Work done by friction is equals to frictional force into displacement, and frictional force is in leftward direction, means upward direction, displacement of the block in downward direction, so fs cos 180 degrees. So work done by friction is equals to minus fs, and can I say L perpendicular to the block, n is equals to mg cos theta, mg cos theta. Then work done by friction is equals to minus mu n s. Then work done by friction minus mu mg cos theta into displacement, right? Then work done by friction is equals to minus mu s is 0.25, m is m only, g cos 37 into displacement of the object is 5. So this is equals to minus 1.4 m 10 4 by 5 5. These two will get cancelled, these two will get cancelled. Then work done by friction is equals to minus 10 m, minus 10 m. Then work done by gravity is equals to m g h m 10 H value is 3, which is just to be found here. H is equals to, see, H is equals to 3. So work done by gravity is equals to 30 m. Then therefore we are using work done by gravity plus work done by friction is equals to change in kinetic energy, and work done by gravity is 30 m. Work done by friction is minus 10 m half m v square minus half m 0 square, because this is kinetic energy final minus kinetic energy initial, right? Now this will be vanishes, right? M will get cancelled. 20 into 2 is equals to v square, then v is equals to under root of 40 meter per second, 40 meter per second, right? This is the answer for b bit. Now let us go through the second example. Let us go through the second example. And in this example, a smooth block of mass m is released from the rest. Actually they didn't, I forgot to take the diagram. Actually it is having a diagram like this. It is having a diagram like this, right? And a block is placed here, a block is placed here from a height h, from a height h. It slides and compresses the spring of stiffness constant k. K, find the maximum compression of the spring. See here, the block is coming down and it is attached here, and after that, because of its velocity, it is compressing the spring up to some point. And what would be the maximum compression? Maximum compression. And note one point here, here work done by gravity, work done by spring, change in kinetic energy. By using work energy theorem, we can write like this. And work done by gravity is, see, from height h, it is coming to the horizontal surface. So mgh, and displacement is in the downward direction. Mg is also in the downward direction. So mg is in downward direction. Displacement is also in the downward direction. So theta is equals to 0 degrees. Obviously, I can write directly mgh. Mgh cos 0 actually, but I am not writing cos 0 because we are already familiar with. And work done by the spring is half k x square, and change in kinetic energy. Kinetic energy final value, that means object is coming to rest, and kinetic energy initial value, that means object initially also starting from the rest position only, right? That's why I am writing these two. And mgh is equals to half k x square to mgh by k x is equals to under root of. This is what is the answer for the given question, right? And next point, right? Actually this is the final question, and according to our rule, according to our rule, we have to give a question as your homework, right? And try to solve this question. And if you need any assistance from my side, let me know through the comment box. I will definitely give you the response. And for daily practice sheets and weekend examination papers, you better to follow our telegram channel, Physics with Jagan sir. Have a great day, take care, bye bye. And but don't forget to solve this question, right? Bye bye.